Thanks a lot. Thanks, man. Cool. So yeah, I actually moved from academia to industry, and now I mainly work for Trend, which is officially an AV company. So I should do malware detection rather than web, but I work like in the research department of Trend, which is pretty good because we can basically work on different topics. So we do not only focus on malware, we also work as for example in this context in web security. We work on privacy of social network. Recently we are also working a lot in the domain of Internet of Things. So like attacking anything from FreeGuard to cars or anything you can think about. And we also do a lot when it comes to cybercrime investigations. So we collaborate a lot with like law enforcement for different operations like takedown of botnets or ransomware campaign. Okay, of course, I think I share probably the common background as most of you guys here. So I've been very active in the open source community and the hackish community since more than 10 years. So like CCC camp and any kind of old school hacking camp was something that I really enjoyed in the past, and I'm still doing it. So what I'm going to talk today, as you can see from the title here, is a work I did with two colleagues of mine from RuhrSec Institute, which is a research lab located in South France. We published this work at www 2016 a month ago, so it's pretty recent. So what we did, we basically built a system to extract what's called indicator of compromise. In particular, we did it for web application. So let me directly jump into the topic of what is an indicator of compromise. So an indicator of compromise is normally used in incident response operation as much as in computer forensic. Because the indicator of compromise is actually a forensic artifact that is used to indicate whether a system has been either compromised by an attacker or has been infected by a malware. So when there is, if you work like with in a company that does consultancy service and you do like a forensic analysis of a system, what you look for indicator of compromise. So you look whether, for example, there is a specific file in for example, in a temp directory or in a directory that is often used by as a dropper zone by the attacker, or whether there is a specific registry key in the Windows registry. Or you can also look it from a network standpoint. So if you see that there are like very weird outbound connection, it could be, for example, that some of the machines in the network have been compromised by a botnet. So in that case, you will see probably some traffic going out to the command and control server. That's, for example, an indicator of compromise for a specific malware installed on the network. You can also look at logs. So if you see like a lot of like login failures on your, I don't know, SSH server, you might think that somebody is trying to brute force your account. So these are examples of indicator of compromise that are widely used by analysts worldwide. So what we did in our work was to extend the concept of indicator of compromise to web application, which is something new, I've never done before. And on top of that, we also build the system to automatically detect them. And as a consequence, since we are able to detect an indicator of compromise, we are able to detect all those web applications that have been compromised, okay? Because they include somehow in the web application the indicator of compromise. So let me share with you a couple of screenshots about the face bands. And then you can tell me, what we have in common. This punk cyber parrot from where? Yeah, from Pakistan. Then you have this nice defaced by team Teach with a skull and some kind of matrix background. And then you have that. So do you know what they have in common, these three? Somebody can guess it? So what they have in common is that they have a similar background. So the three of them, this one they have Thunderstorm, The other one, we have a kind of matrix style background. So this simple observation is that when an attacker compromises a web application, what often does, he relies on external content, what we call accessory scripts. For example, in this case, to render the page. So it could be like the CSS they use to have like the thunderstorm of the background, or to have like a matrix style fashion like background. And this kind of accessory script, interestingly, they are not necessarily malicious. Like in this case, this CSS used for a background is not malicious, okay? But their presence can be like what we call indicator compromises. So can be tell us, look, this page might be compromised because it includes this background. So some of example of these accessory scripts are, for example, popular JavaScript libraries, as could be like jQuery, or beautifier that control the look and feel of a page to make it like, for example, often the defacer they use they have a background, they have a noise, some music in the background, or they have some images promoting their hacking group. Or beautifier like to make their page like cool because they are lit, because they want to actually be proud of their defacement. Or you can have like scripts that implement reusable function, such as browser fingerprinting. That's very common, for example, when they compromise a page and they install like an exploit kit. So in that case, all the exploit kit up there, what they do, they basically fingerprint your browser to serve you the best exploit based on the configuration of your browser, if it's 32-bit or 64, if you're using Chrome or another type of browser, or a specific version of Flash, for example. So that kind of code is often reused over and over, and it's not really malicious. It's just a fingerprinting, a code that fingerprint your browser. So interestingly enough, the fact that these scripts are normally like not malicious, their innocuous form make them highly resistant to traditional detection system. What does it mean? It means that if you have a scanner that do like static code analysis, or if you have a dynamic code analysis system that run, for example, with JavaScript in a sandbox, if a JavaScript per se, the content of JavaScript is not bad, most likely the scanner won't be able to flag this piece of code as bad, okay? And will get basically unnoticed by traditional scanners. But the observation is that their presence can be used to precisely pinpoint compromised or harmful pages. The presence of such script on your site. And this is what we call a web indicator of compromise. So let me start with an example. So this is an example of a code that we found on a compromised web page. So you can see the attacker changed the title of the page and then include a script, okay, referencing an external URL. If we open this URL, we can see that what this JavaScript does, it's just it creates like a fake image tag, and then what is set like the source of the image to that URL. What it does this is basically generate a get, okay, to that specific URL, and encoding the get to the PHP script, PHP file, the location of the page. Okay, so why the attacker does that? The attacker does that because often what they do, they use like automated scanners to compromise a wide number of web applications. So in order to keep track of which site they have compromised, they use this system to ping back basically the command and control server, so that the attacker knows which machine his scanner has been able to compromise. So it's basically a system to keep track of a list of sites they were able to deface. And this is clearly not used in a malicious context, even if the code itself is not bad. So the code itself of this JavaScript does nothing bad, so it does not contain any heap overflow, it's not a drive-by, or it just basically force the browser to connect to a specific URL and leak like the URL of the page. So this is an example of indicator of compromise. And to show that this indicator of compromise is actually benign, so the code itself is benign, I can tell you that, for example, VirusTotal tell me that only 5 out of 62 AVs detect this URL as malicious. But if I submit like the content and they ask to analyze the content, none of them tell me that it's bad. And they're right, because the code, as I said, the code itself is benign. Okay, so how can we identify this code as being used in a malicious context by some bad guys? So this is actually the scope of our work. So how do we know that a script is used in malicious context? That is, how do we know that this specific indicator of compromise is valid? What I say when I say valid, I mean used in malicious context. So we start our work by deploying a web honeypot. This is a previous work made by some colleague of us. So what we have here is what is a honeypot made, a high interaction web honeypot made of 500 domains that point to different vulnerable web applications. So we have web applications, like common web applications like WordPress, Joomla, as much as some custom web application with different type of vulnerabilities, mainly SQL injection or common injection, which are the easiest server-side vulnerability being used by attackers to compromise a web application. And what we do, we run this web application in Linux containers inside virtual machine. At that point, what we do at runtime, at midnight, we take a snapshot of a VM and we make a diff of a snapshot with the original original VM, such that if the VM has been compromised and if attacker has ever uploaded some files or changed some files or tamper with a application, we can basically automatically extract that forensic artifact, and then we store everything in a database. Of course, during runtime, after we did that, we also revert back the snapshot to the original version of a VM to prevent basically the bad guys of using the VM over and over to attack somebody else. On top of that, everything ran into this virtual machine container, so we have also firewall outside VM to prevent outbound traffic and other precaution. So what we do, as I said, we automatically extract candidate from files that are being uploaded and modified by the attackers. Uploaded can be like new files, for example, if attacker can install new Webshells, or modify where, for example, the attacker take a existing page, they add something, the existing pages could be some JavaScript, as I show you later in the presentation, some JavaScript do something, okay. We explicitly focus on the JavaScript URLs, so this is what we extract, JavaScript URLs, but of course, the research can be extended to other resource type. It could be like images that are often used by attackers, or MP3 that they attach to the deface page, anything else. So as I said, these JavaScript are normally benign. For example, attackers very often use like a script that block the right click of a mouse, which seems like very stupid, but actually they use it a lot because they do not want that visitors that load the page, the face page, they don't want the visitor to look at the source code of the page. Okay, and we that are expert, we just do Control U and we look at the source code, but the normal user right click with a mouse and do right click and then view source code. So they use this kind of system to prevent. So as I said, these scripts are clearly benign, but we are using malicious content. So it's very difficult by looking at the content to understand whether this is a valid indicator of compromise or not. So what we have to do, we have to extend the analysis to the context around this JavaScript URL. So what we do, we look for public web pages that include reference to our indicator. Okay, so we have this web honeypot, we extract these JavaScript URLs, and then we look over the internet for all those pages that include a reference to our JavaScript URL. So we first said, okay, let's use Google, I mean, we all know we use Google, so Google should help us on that. But Google all index the content of a page. So you can search for the term that is in the content of a page, but not in the source code itself. And it does not support JavaScript, so you cannot search for at least the in-text tag doesn't support that. So we use a man path, which was free to use when we did the research last year, and now you have to pay for that. But manpath is great because it has HTML and JavaScript source code support, and you can easily query. I can ask, give me all pages, including in the source code, this URL. And we have a coverage of 200 million websites, which is not much, but it's not few, which is pretty okay for a proof of concept. So we build a crawler for manpath, and we search for each of these URL. We extract the first 100 websites, including the URL into the source code. So what the system does, it then uses machine learning to understand whether this JavaScript URL is actually a valid indicator of compromise or not. And here what it does, it uses different features for that. I'm not sure if you're an expert about machine learning, so I don't want to go too much in detail, but I want to give you some insight of how the algorithm works. So we have 5 different features that allow to discriminate whether an indicator of compromise is valid or invalid. So the first feature is page similarity. So the idea here is that attackers very often use the same template when they deface a page. This is very common, for example, for hacking group, that they use the same methodology, they use the same template to advertise their compromise. So the page they compromise, when they compromise a page, they often use the layout they use is similar. So they have often the same button, like we have Facebook and Twitter button pointing to their hacking group website, just to advertise their defacement. They have the names of a member of a hacking group, and or you can have groups that do deface only for a specific with a specific goal, like for phishing, for example. So in that case, they all contain the same phishing kit. So we look for out of this page that we extract from manpath. We look for the similarity of the page that include our indicator of compromise. So here we use SSDeep, which is an algorithm to compute the similarity between, in this case, web pages. It uses a phashing algorithm of doing it. So what we do, we compute this page, the similarity between these 100 pages, and we use this value as one of the feature for our algorithm. The second feature we use is maliciousness. As I said, most of these indicator compromise are normally benign, but they're often included in pages which are malicious. So if out of these 100 web pages, including our indicators, if some of them are malicious, so most likely also all the other are malicious and the indicator of compromise is valid. So what we do, we automatically query for Google Safe Browsing, virus total, and the web reputation system of a company I work on to see whether these pages are malicious or not. And we use that number as one of a feature for our classification algorithm. We then look wherever there is an anomalous origin. What does it mean? It means that we often find out that attackers, instead of using the JavaScript, for example, take jQuery, instead of using the URL of the official jQuery domain, what they do, they take jQuery, the source code, they download it, they upload it somewhere else, usually in, for example, in web server that they compromise in Russia or Ukraine, and they host their code there. Okay, so the code itself is exactly the same as the original code, but instead of using the official URL, they use that one. This is used because if they want to do some changes to the code, they can easily do the change on the code on their side, on their domain, and automatically all the page that they have compromised will basically load these changes. So what we do, we look wherever the URL which is loaded in the JavaScript, the domain itself is different than the original one, and if I use multiple domains for hosting the same piece of code. Then we look for a popularity of a JavaScript. For example, if you take the SDK of Facebook, okay, the SDK of Facebook is widely used. It's basically this button that allow you to this JavaScript that allow you to create this button like for I like or like share on Facebook. This kind of components are highly used, so it's very rare that they are used only by the attacker. So we don't want to flag that as an indicator of compromise. And then we look for an automated way for security forums. So wherever somebody has already discussed about that specific URL. So we query for the URL and the list of keywords like hack, defaced, compromise, and so on and so forth, to know if somebody else has already discuss about that specific URL. So we use these five features. We use a framework called Weka, which is a framework for machine learning, and we use Weka on a training data of 4 months for a total of more than 300 unique candidates. And we do clustering based on our training data. So what does it mean? It means that we build basically the 3 cluster categories. So out of all the JavaScript URL that we extract from our training data, we have 3 groups. Those ones that are used in a malicious context, that we call valid indicator of compromise. Those that are benign, and those that are undecided, because we didn't have enough information. Usually this is the case when mean path does not give us enough pages to run the algorithm to. For doing that, we use a supervised learning algorithm called k-means. In this case, we use the values of k equal 8, which was working good. So at the end of that, we have basically this 3 big cluster. Okay. What happened then? We went live with the tool. So starting from middle May, what the tool does on every night, he extracts the JavaScript URL from the web honeypot. He processes the JavaScript URL using the system, and they look for a distance. So basically tell you, okay, this JavaScript URL, it's very close to the malicious cluster, so it's most likely malicious. This JavaScript URL is very close to the benign cluster, so it's most likely benign. So, and you do it in real time, okay? So, in average, we extract 2.5 indicator of compromise per day, unique compromise per day from our web honeypot for a total of 300 candidates. And it turned out that 22 were benign, and roughly 100 of them were actually malicious. And interestingly enough, 90% of them were previously ever unknown, completely unknown by traditional AV, so like if I query for VirusTotal, nobody knows about them, or they were misclassified as benign. And one of the reasons is because 1/4 of these 100 malicious indicators, they were actually used for visual effects, like moving text in the page, or the snowing effect, that kind of things. But we actually verified that they were only used in malicious context, so they were not used in any benign page. So let's go a bit into more detail here. So this is a plot about the lifetime of malicious indicators. So as you can see, there are like the majority of them, they have a lifetime of less than 150 days. That means that they've been around just for a couple of months. But there are some of them that have been around for like 300 days, or 1 year, or 2 years, or more than 2 years. And interestingly enough, 10% of these indicator of compromise were hosted on Google Drive or Google Code. So like Okay, well, I was expecting that we were hosting them, as I said, in compromised web server in Russia or somewhere else. But actually, 10 of them were actually hosted on Google Drive and code. We show that it's very difficult to detect such JavaScript because JavaScript itself is actually benign. And one of these were online for over 2 years. And the last time I checked, it was still used by a dozen of defaced websites. So these websites, they were all defaced by the same hacking group, and they were all including the same JavaScript, which was, hosted on Google. The same JavaScript was also used for a drive-by, for web malware infections. So let me now give you some example of what we found with the tool, with the system. The system actually is still running, so we are constantly find new things here. So one of the common things that you find is Webshells. So because when you get compromised, one of the first things that the bad guys do, they install a web shell to keep persistence on the compromised machine. We have several cases of password protected logins. So we have a JavaScript that manage all that together with a CAPTCHA and custom CAPTCHA and so on. This was automatically flagged as a valid indicator by the system. Then there are different cases of this R57 shell script I showed you before. This is very common, as I said, because it's a way that attackers do to basically acknowledge the fact that their tool that they use for mass defacement efficiently defaced a web application, and to keep track of which application they have defaced. Okay, I have 15 more minutes, but it's more than enough. And I want to tell you something about this R57. Actually, I found out, I don't know if you were aware, that these web shells were actually backdoored. So if you're a bad guy, okay, you go on their site, you download the web shell, you use your web shell in your attacks, and then the web shell itself is basically backdoor. And this allow the bad guys, the guys behind the development of these R57 shells, to connect to the machine that other people have compromised. Okay. And another common habit for attackers is to install phishing kit, because phishing kit is very easy way phishing is a very easy way to get money out of the face. So what they normally use, they use phishing kit that are kind of ready to use. So we found a lot of phishing kit for webmail portals of American Online and Yahoo. So in this case, they were using the original JavaScript files and for rendering the page. And when I say the original, it means that the file and also the location URL. So the domain of this JavaScript file were actually the official authoritative domain of the American Online, as you can see there in red on the first line. So I'm pretty proud of the system that was able actually to identify these cases. And how we do it? We do it with the fact that there were multiple websites that were being compromised by the same gang, and such as UCI, logistic.com and fernand.whatever.com. So the system automatically flags that as bad because you have actually multiple domains that are different by the domain that the first domain there, American Online CDN.com, and that's something rare. Because if you have a web portal for American Online and use a JavaScript from American Online, normally also the web portal should be hosted on American Online or a subdomain of American Online, and this was not the case. So we have multiple websites comprising the same group on different domains, and this was one of the features of our classifier. That's why it actually shows that the system works and currently flag all these indicators as a malicious, as a valid indicator of compromise. But another way to make easy money for criminals is what's called affiliate programs. Okay, I guess you all know how an affiliate program works. And so, for example, the case of this URL. This URL is a URL related to a JavaScript that has been installed on a lot of the face web pages that we collect from our web honeypot. So this is a traffic redirection system for affiliate programs. What does it mean? It means that all the victims that visit the face pages, they get redirected to another site, okay, that will collect the visit. And the bad guys, they get actually some revenue out of the visits, okay? So basically they steal the click or they steal the visit of legitimate users. So on top of that, interestingly, this URL is also loaded at client side by a malware called visa.com. So this is something we found out later, and it's also another way, to exploit this affiliate campaign system. And using the telemetry in our AV, we found that roughly there are 600 new infected users per day. So this threat is still ongoing, and actually we are the first one to uncover the fact that on top of using this JavaScript at client side by malware, what the bad guy did, they also use the JavaScript at server side as a traffic redirection system. Similar to that, there is this fake charity program from donationtool.org. So if you go on this site, they claim to be a very illicit, like a shopping site, such as Amazon, but you can actually not, but if you go on donation tool, you can shop for anything, like anything you want from IT or whatever, and they basically claim that part of a cost of what you spend there will be donated to American Red Cross and a bunch of other like charity program, which is clearly true, no? And so we found this URL in our as indicator of compromise, and this was loaded at runtime as a BHO, browser helper object, in Internet Explorer by a couple of malware families. And we also verified there were like about 600 new infections per day. And this case is similar to the previous one. So this JavaScript was also installed at server side on compromised web pages. So basically this guy behind the donation tool, they were using both, a client-side approach, like a malware, to collect visits, as much as, as I said, like the face pages and traffic generation system at server side to collect visits. So like two ways of better, exploiting, just stealing clicks from legitimate users. But another case are mailers. So this is very common as well. So what the bad guys do here, they compromise a site and they turn the compromised site into a spam mailing server. They usually do using like a PHP mailer, mailers made in PHP or in other web code. And this is an alternative way of installing a mail server, alternative to bulletproof hosting providers that are commonly used as well. To use this hosting provider, usually located in east of Europe, or to use a botnet infected machine, but also another way of doing spam. But very common is also to use compromised website. So we found a lot of instances of compromised websites installed with a ProMailer version 2, which we found out to be like a PHP mailer written in Russia and sold commonly on Russian underground forums. And this tool uses copies of jQuery, but in this case, jQuery was no, actually, what I want to say is jQuery was hosted on Google and Tumblr, and this was these were unmodified copy of this popular library, which was very difficult to for our classifier to classify as malicious, because the jQuery was a legitimate jQuery, was hosted on Google, and so on. But at the end, this was classified as malicious, and there are a couple of websites that have been compromised by this gang, and they were actually classified as one indicator of compromise. Of course, our system is not perfect. That's important to say. We think that the approach we use is a kind of alternative approach to existing solution, like a system that look at the content. Instead, what we do here, we don't look, as I said, at the content, but we look at the way in which the attackers made use of their JavaScript, in which form. For that reason, there are some evasion techniques. So the fact that attacker can use like inline code, so can embed like the code inline in their defense pages rather than referencing the external component. The fact that they can also use one-time generated URLs. So every time they infect a new machine, they could actually the URL they include can be generated in a different form every time. A kind of DGA at server side. And may actually be something that they are already doing, server-side DGA. To conclude, I think what we did here, we introduced this concept of web indicator of compromise, and actually we have this system in place that use open source technology to detect valid indicator of compromise. And it's pretty helpful in detecting websites that have been compromised by, for example, the same hacking group. Including sites used for phishing or for affiliate programs, as much for installing drive-by downloads. We also use this indicator of compromise together with HTTP referrer to discover compromised pages on the backend. So this is actually what we are doing now, and we also do it for doing investigative analysis, like when it comes to understand what's the surface of a specific hacking group. Using this technique, we can understand, if a specific group, how many websites they faced, where are they located, why they do the defacement or not, which type of site they target. So when we come to really doing intelligence operation, understand the surface of these groups. That's very helpful. I hope you like my talk, and whenever you have questions, you can just reach me out. I will be around today, or just drop me an email. So thanks a lot.